Quadratic equations have solutions called, what's that other word we use instead of solutions? Proofs. Good. So roots of quadratic equations can be found by plus minus square root when there's no x term. Factoring and setting each factor to 0 if there's an x term. Or the quadratic formula if there's an x term but you can't factor. Actually, the quadratic formula you can use for any type of quadratic equation. Sorry, this should say x. But the quadratic formula, technically, you could use whether there's an x term or not. So this is all algebraic. Now, maybe I can spell it. Algebraically. You're doing some type of manipulation to the equation. What we just discovered in those two examples that we did is we can also solve them graphically. As in, graph each side of the equation. Y equals in front of these. Find the x value or values. There could be more than one. Usually with quadratics, there's going to be more than one because every time we've been solving these, we've been usually getting two solutions. Sometimes we get none. Sometimes we get one. So find the x values of the points of intersection. Points or points of intersection. These will be the solutions. Okay. Well, we've already done a lot of algebraically. In fact, we've done the whole unit on it. So let's just look at, I've got 3 more examples of this, but I think we can do just one and we'll be okay. I'll let you look at example 2 and 3 in the notes if you need to, but let's do this one. So the first thing you want to do is just toss a y equals in front of each side. That's in front of the left side. That's in front of the right side. If it's just got a y, it's always going to be a horizontal line. Where every y coordinate is 0. Well, that's the x-axis. Here's y equals 0. So you have to graph that. You're just drawing a line over top of a line that's already there. The parabola takes a little bit more. How are you going to find the vertex of this parabola? negative b over 2a, which means I get negative 6 over 2 times 1, which works out to 3. Take that 3 and plug it back in to find the y vertex. And I get 3 squared. Don't need the parentheses because it's not a negative. But you could put them if you want. You need the parentheses here. Looks like I get 9 minus 18 plus 9, which all works out to 0. So the vertex is 3, 0. Where's 3, 0? Up or down? Up, stretch or no stretch? No stretch. So 1, 1, back to the vertex 2, 4. Ooh, that was a shaky one. Not quite done yet. To solve it by graphing, you have to identify the solutions. So circle it here. State the x value. That's a complete solution. Often students will not graph this horizontal line. Graph it for full marks. Students will graph this and then stop. Because they're so happy that they graph both sides. But then they won't circle where the intersection is and state the solutions. Remember, the ultimate goal is to solve. Okay? Okay, so like I said, if you look at page 2, they're very similar. Okay? Here, you would do the same thing as we did on the previous one. Okay? We'd have to use the negative b over 2a to find the x vertex, plug it back in to find the y, graph the other side, which is a horizontal line on the x-axis, and then we get the points of intersection. There should be 2 this time. Okay? So I'm not going to go through the whole thing here. Well, this one we could actually do without negative b over 2a. We don't have to, because all this is a parabola that goes up 4. Its vertex goes up 4, so its vertex starts here, but then it goes down. And it's going to intersect y equals 0 here twice. So again, there's really nothing new here. And like I said, you can see those solutions if you go to the completed notes on Teams. Okay? But I think we've had plenty of practice. Now, notice all the ones that I put in this lesson. The right side is always 0. Okay? Which is usually the way quadratic equations are supposed to look when we solve them by factoring of the quadratic formula. Well, really, what we're doing, like if I just do this one very quickly. So I go up 4, opens down, but it's regular. It's going to look like this. Here's the horizontal line. Here's the solutions at x equals 2, negative 2 here, and x equals 2 here. Whenever I find the intersections on the x-axis, what's another word for these points? Points that are on the x-axis that a line or curve goes through. Intercepts. Okay? The x, like to find the y-intercept, well, the y-intercept is 4 for the parabola, right? Because it's the point that goes through the y-axis. Well, so really what we're doing when we solve these, whenever the right side is 0, we're finding the x-intercepts. So for the last example, because you may see it like this, you're given this, and you're asked to find the x-intercepts. So remember, to find the y-intercept using algebra, we make x equals 0. To find the x-intercepts, usually there'll be more than one, we make y equals 0. That's how we find x-intercepts algebraically. So in this function, just replace the y with 0, and we've got ourselves a quadratic equation. The point that I'm trying to make is all those ones we did graphically in this lesson, we were finding the x-intercepts. That's what we were doing. That's when one side is equal to 0. How are you going to solve this one? Factoring? Did I hear?
Yeah.
Yeah. What we got?
4 and 2.
Full closet. So remember, we're not done. So one x-intercept plus 4 is equal to 0. So this x-intercept would be negative 4. That's 1. The second x-intercept would be when the other factor is set to 0 and we solve, which is negative 2. So what that means is if you were to graph each side, they would each side would intersect each other on the x-axis of those 2 points. Okay? So that's doing it graphically. That's all we're going to look at graphically this year, but we're going to look at it more next year too. Okay.